Hey everyone, and welcome back to AI Paper Podcasts. Today we're taking a deep dive into a paper that explores how LLMs can actually teach themselves to get better at forecasting.
It's really kind of like giving these models the ability to learn from their mistakes and refine their predictions over time without us humans needing to constantly step in.
That's a really great way to put it, and it's something we'll unpack more as we go. I mean, forecasting is everywhere, right? Finance, economics, public health, policy making.
Yeah, it's a critical component in so many fields. So naturally, any advancements in this area are going to have a ripple effect across a ton of different industries.
Exactly, and that's what makes this paper by Turtle, Franklin, and Schoenegger so interesting. They're really tackling this challenge of improving LLM forecasting head on.
And one of the things that really stood out to me was how they're challenging this assumption that we need these massive resource-intensive models to achieve state-of-the-art results in forecasting.
Yeah, that's a big one. You don't always need to throw the biggest model at the problem.
Right. They show that even relatively small LLMs can achieve some pretty impressive accuracy with the right training techniques.
That's so encouraging, especially for researchers and developers who might not have access to these massive computing resources.
It levels the playing field in a way.
This paper really caught my eye because it digs into how we can make these models less reliant on us humans.
Yeah.
Like right now, we're still better at what's called judgmental forecasting, where we take into account all sorts of complex factors and evidence.
Yeah, things like, if you're trying to predict the outcome of an election, you'd consider polling data, economic indicators, social media sentiment, even historical trends.
It's a very nuanced process, and humans are still pretty good at weighing all those factors.
Exactly. But the problem is that a lot of the current methods for improving LLM forecasting still rely on us to feed them curated data or provide up-to-date forecasts, which,
It's time-consuming, expensive, and it just slows everything down.
Absolutely. And the authors of this paper make a really compelling argument that we need to find ways for these models to learn directly from outcomes.
Which brings us to their approach. It's pretty clever. They leverage this concept of self-play.
Yeah, self-play, which, gained a lot of attention with AlphaGo, that AI that mastered the game of Go.
Yeah, that was a huge moment in AI history.
Yeah.
But how did they apply this idea of self-play to forecasting real-world events?
Okay, so essentially they used self-play to have the LLMs generate tons of different reasoning pathways and probabilistic forecasts for a set of real-world events.
So almost like a massive brainstorming session for the model.
That's a great way to think about it. It's exploring all sorts of potential scenarios and outcomes.
Okay, but how do we make sure these brainstorming sessions actually lead to accurate predictions?
That's where another really cool technique comes in, direct preference optimization, or DPO.
I've heard of DPO before, but how does it apply here?
It's all about learning from rankings. So the model generates these multiple reasoning pathways, right? And then DPO figures out which of those pathways actually lead to more accurate predictions based on how close those predictions were to what actually happened.
So it's almost like the model is getting feedback on its thought process and learning from its mistakes.
Exactly. And one of the really nice things about DPO is that you don't need to create this separate reward model. It learns directly from the rankings of those predictions. So it's very efficient.
Okay, I'm following. So we've got self-play generating all these ideas and DPO helping the model figure out which ideas are the most promising.
Right.
But what were they actually trying to predict? What kind of real-world events?
They used a data set of over 12,000 binary questions from the Polymarket prediction market.
Oh, interesting. So these are questions with a yes or no answer.
Exactly. And they covered a wide range of topics.
Like what?
Well, some of the questions were about whether specific events would happen, like, will Sam Altman attend the presidential inauguration? Or will FTX start payouts in 2024?
Those are definitely questions people were asking.
Yes, very relevant to the world of AI and tech.
Did they just give the models the questions, or was there any additional context?
No, they didn't just give them the questions. They also used the Newscatcher API to give the models relevant news articles from the 14 days leading up to each question's resolution.
Smart. So it's not just predicting in a vacuum, they're getting real-world information.
Right, exactly.
What about the models themselves? Were they using these massive state-of-the-art LLMs?
Actually, no. They chose two relatively small but powerful LLMs, 5414B and DeepSeek R114B.
Interesting. Why those two?
Well, these models were chosen because they'd already shown really strong performance in other complex tasks like coding and mathematical problem solving.
Oh, so they hit a track record.
Exactly. And they wanted to see if these smaller models could hold their own against much larger models in this realm of forecasting.
So did all this self-play and DPO training actually pay off?
The results were pretty impressive. Both models showed a significant improvement in forecasting accuracy, around 7–10% over their base versions.
Nice. But wait, they also included a control group, right?
Yes, to really isolate the effect of learning from outcomes.
How did that work?
So they had a separate set of models that were also fine-tuned with DPO, but instead of being ranked based on the actual outcomes of the events, they were ranked using randomized labels.
Oh, clever. So it's like they're getting the training, but not the actual feedback from reality.
Exactly, and
Yeah.
this helped them determine whether the improvements were truly due to learning from outcomes or just from being exposed to more data.
That's a smart way to control for those variables.
And what they found was that the models trained on the actual outcomes significantly outperformed the control group.
So it really shows that it's not just about the data, it's about how they're learning from it.
Precisely.
So the models that actually learned from the real outcomes did better. What kind of accuracy are we talking about here?
The results were really quite remarkable. Both models, even though they were much smaller, achieved comparable accuracy to GPT-4o, which is a much larger and more resource-intensive model.
Wow, so even though they're smaller, they're punching above their weight class.
You could say that, to put it into perspective, GPT-4o achieved a mean Brier score of 0.196, while 5414B scored 0.20, and DeepSeek R114B scored 0.197.
That's really impressive considering the size difference between the models.
Absolutely.
Okay, they're getting pretty good, but I'm assuming they're not perfect.
Yeah.
Did the researchers look into what kinds of errors these models were making?
Yeah, they didn't just look at average scores, they analyzed the whole distribution of results. And they found that while the fine-tuned models did occasionally make some big mistakes, they also made many more highly accurate predictions than the base or control models.
So it seems like there's a trade-off there, but potentially a worthwhile one.
Right. And that's what makes this research so exciting. It's really challenging our assumptions about model size and performance, and it points towards a future where AI forecasting is more accessible and impactful than ever before.
It's definitely a promising direction. Now, before we dive into the broader implications of this research and what it means for the future of AI forecasting, let's take a little closer look at some of the specific techniques they use to achieve these results.
Absolutely. Let's unpack those prompts they designed and the Brier scoring system they use to evaluate the models. There's a lot to learn from those details.
Perfect. Let's take a break and we'll come back to that.
Welcome back.
So before we get too deep into the results, let's talk about how these models are actually generating these predictions. You mentioned prompts earlier, and I think our listeners will want to hear more about that.
Absolutely. Prompt engineering is key in this kind of research. So remember how we were talking about how good human forecasters rely on things like structured reasoning, considering different viewpoints, and even a bit of that super forecaster intuition?
Yeah, like weighing the evidence carefully, trying to avoid biases, thinking about all the angles.
Right. The researchers wanted to instill those same principles into their LLMs, so they designed their prompts to really encourage that kind of expert level thinking.
I love that, like taking inspiration from human expertise and turning it into instructions for AI.
Exactly.
Can you give us an example? Like, what did one of these prompts actually look like?
Sure. Let's look at the prompt they used for 5414B. It starts by giving the model the question, background information details about how the outcome will be determined, the closing date, and then those news summaries we talked about.
Okay, so setting the stage.
Right. Then come the instructions, which are broken down into steps. First, it asks the model to rephrase and expand the question in a way that'll help it understand the problem better.
So it's almost like they're prompting the model to think critically about what's being asked.
Precisely then, the prompt tells the model to come up with reasons why the answer might be no and to rate the strength of each reason.
Okay.
Then it does the same thing for reasons why the answer might be yes. So this is where that structured thinking and considering different viewpoints really comes in.
It's like forcing the model to play devil's advocate with itself.
Yeah, I like that analogy. And it gets even better after the model generates its list of pros and cons. The prompt tells it to aggregate all of those considerations and think like a super forecaster, referencing experts like Nate Silver.
It's like a crash course in super forecasting.
Right.
Okay, so the model has brainstormed and reasoned. What happens next?
At that point, it gives an initial probability, but the prompt doesn't stop there. It challenges the model to think about whether that probability is too confident or not confident enough.
Oh, interesting. So it's like a check for bias and overconfidence.
Exactly. And finally, after all this back and forth, the model outputs its final prediction as a number between 0 and 1.
Okay, that is a seriously comprehensive prompt. Did they use the same approach for DeepSeek?
The prompt for DeepSeek was similar in spirit, but a little more concise. It relied heavily on what we call expert persona, prompting, essentially telling the model, you are an expert super forecaster familiar with all the best techniques. Now go and make your prediction.
Straight to the point. I like it. So both prompts were really carefully crafted to get the best possible forecasting performance from these models. But how do they actually measure that performance? You mentioned Brier Scores earlier. Can you remind us what those are?
Sure, the Brier score is a way to measure the accuracy of probabilistic forecasts. Basically, the lower the score, the better the prediction. A perfect score would be 0, meaning the model predicted the outcome with 100% certainty,
Yeah.
and a score of 0.25 would be like flipping a coin, pure chance.
Got it. So lower is better. What were the Brier Scores looking like for these models?
This is where it gets exciting. The Brier scores tell us that both of the fine-tuned models outperformed their base versions significantly, which shows that the self-play and DPO training really made a difference.
Can you give us some numbers?
For 5414B, the fine-tuned model got a mean Brier score of 0.200. This is a big improvement over the base model score of 0.221, and DeepSeek R114B did even better with a score of 0.197 compared to 0.212 for its base version.
Those are some serious gains. And remember, this is with relatively small models.
Right.
But how did they compare to the bigger models like GPT-4o?
This is really interesting. Both 5414B and DeepSeek R114B, even though they are much smaller, achieved comparable accuracy to GPT-4o, which had a mean Brier score of 0.196.
So these smaller models, after being trained with self-play and DPO, were going head-to-head with one of the most powerful LLMs out there.
It's pretty amazing, and it highlights how these training techniques can unlock impressive performance even in smaller models.
That's huge.
Yeah.
Okay, so we've talked about the prompts, the models, the performance. Is there anything else about how they did this research that we should touch on?
Yeah, there's one more really important detail I want to mention, and that's how they controlled for the influence of the news data. Remember, they were feeding these models news articles that were relevant to each question.
Right.
So how do we know the improvements weren't just because the models were getting more information?
That's a great point.
Yeah.
It's not just about throwing more data at the problem.
Exactly. To address this, they created that control group we talked about earlier.
Right.
These models were also fine-tuned with DPO, but their rankings were randomized instead of being based on the actual outcomes.
So they're getting the training, but not the real feedback.
Right, and what they found was that the models trained on the actual outcomes did much better than the control group.
So it really shows that it was the learning from feedback that mattered.
Exactly. It's not just about having more data, it's about teaching them how to think. Like expert forecasters learning from their mistakes and refining their predictions.
And that's what makes this research so interesting. It points to a future where AI can play a more active role in helping us understand the world.
Absolutely.
Okay, so we've unpacked the methodology and the results. Now let's shift gears a bit and talk about the bigger picture. So we've spent this deep dive looking at how LLMs can basically teach themselves to become better at forecasting.
Right. And, one of the things that I think is really important to take away from this is that we might not always need to rely on these massive computationally expensive models to get really good results in forecasting.
Yeah, I mean, that was a big takeaway for me too. The fact that these smaller models with the right training methods were able to perform at a similar level to models like GPT-4o. It's pretty amazing.
It really is. And, it kind of challenges that idea that bigger is always better in AI, which is exciting for people working with limited resources,
Definitely, it opens up a lot more possibilities for innovation.
Absolutely.
And when we think about where we could use this kind of technology, I mean, the potential applications are huge.
Oh, yeah, absolutely.
Imagine being able to predict things like disease outbreaks, natural disasters, economic shifts with greater accuracy.
Right. I mean, it could have a huge impact on how we prepare for and respond to these events.
And I mean, that's just scratching the surface, right? We could use it for things like supply chain management, personalized medicine, financial modeling.
Yeah, the list goes on and on.
It really is a paradigm shift in how we think about AI and its potential to help us understand the world.
It really is.
But of course, like with any new technology, we have to think about the potential downsides too, right?
You're absolutely right. We need to be mindful of the potential for misuse and unintended consequences.
Like if we're using these models to predict things like individual behavior or market trends.
Yeah, right. We need to make sure they're not used in ways that could be manipulative or exploitative.
It's a good reminder that as we push the boundaries of AI, we need to be doing so responsibly and ethically.
Absolutely. Transparency, accountability, fairness, those should be at the forefront of our minds.
So as we wrap up this deep dive, what are some of the key takeaways you hope our listeners will walk away with?
I think it's important to remember that LLMs are evolving incredibly quickly, and their capabilities are expanding all the time. We're seeing them do more and more complex things like forecasting with remarkable accuracy.
Definitely.
And this research highlights the power of using innovative training techniques like self-play and DPO to really improve the performance of these models.
Yeah.
But it's also a reminder that we need to develop AI responsibly. We have to ensure that these powerful tools are used for good and not for harm.
Well said.
Sure.
I think this research is truly groundbreaking, and it could revolutionize how we approach forecasting as AI continues to evolve. It's crucial that researchers, developers, and policymakers all work together to make sure these advancements benefit everyone.
Couldn't agree more. We're at a pivotal moment in AI, and the decisions we make now are going to shape the future of this technology and its impact on the world.
Absolutely. Well, thank you so much for joining us today and for sharing your insights on this really interesting paper.
It was my pleasure. Thanks for having me.
And to all of our listeners out there, thanks for tuning into AI Paper Podcasts. We'll be back next week with another deep dive into the latest and greatest in AI research. Until then, keep exploring and stay curious.